Imagine the modern human condition for a moment. We wake up and we eat, we commute, we grab a coffee with syrup, we snack. We sit at a desk, we eat lunch, we snack again to fight the afternoon slump. Most of us are essentially marinating our cells in a constant, never ending stream of glucose. And the result of this modern lifestyle is everywhere. Sudden energy crashes, pervasive brain fog, and a deep, systemic metabolic exhaustion. But what if the ultimate key to human survival and our long-term biological longevity isn't a new superfood or a complex pharmaceutical, but a dormant switch inside your own cells? What if it all depends on something we've almost completely lost: metabolic adaptability?
It is a profound shift in how we view human health. Because if you look back through the vast majority of human history, food was entirely unpredictable. We didn't have pantries or delivery apps. Humans evolved through intense, unavoidable cycles. We went through periods of feasting, yes, but those were followed by prolonged fasting, relentless physical movement, periods of sheer scarcity, and then recovery. Because of that incredibly demanding environment, the human body had to become an extraordinarily adaptable machine. It was literally forced to be capable of switching between completely different fuel systems depending on what the environment dictated.
And that right there is the core of our exploration today: metabolic flexibility. Modern humans rarely, if ever, experience that flexibility anymore. We are stuck in one gear, and it seems like this metabolic rigidity might now be sitting at the dead center of almost every modern chronic disease we face.
Exactly. Modern metabolism is trapped. We are living in a state of near-constant glucose dependency. Frequent eating, continuous insulin exposure, highly sedentary lifestyles, all of this drastically reduces the body's natural ability to efficiently transition between glucose metabolism and our secondary, fat-based fuel systems, like ketones. This adaptability is the very definition of metabolic flexibility. And researchers are increasingly associating this flexibility with energy stability, mitochondrial health, insulin sensitivity, and long-term biological resilience.
Let's break down those two fuel systems, because I think a lot of people hear the word ketones and immediately associate it with extreme internet fad diets. But biologically speaking, we basically have two main fuel tanks, correct? Glucose and ketones.
That is correct, and it's a very important distinction to make. Glucose comes largely from the carbohydrates we consume, and it circulates rapidly through the bloodstream. It is quick, accessible energy. Ketones, on the other hand, are an alternative energy source produced primarily in the liver during periods of fasting, strict carbohydrate restriction, or prolonged, intense energy demand. Both of these systems are entirely natural, and both are biologically highly useful. The issue isn't that glucose is bad and ketones are good. The key is the flexibility between the two. Healthy metabolism involves the efficient, seamless transition between these fuel states depending on your immediate circumstances.
It makes me think of a hybrid car if you have a vehicle that can run on gas or electricity, but the internal switch that toggles between them is rusted shut because you've only ever used gas. The car eventually breaks down. So the goal here is not permanent extreme ketosis. The goal is metabolic adaptability.
That is a brilliant metaphor. Yes, biology values flexibility far more than extremism. If you are metabolically flexible, you can eat a carbohydrate-heavy meal and your body efficiently processes the glucose. Then, if you don't eat for 16 hours, your body smoothly shifts gears, taps into its fat stores, produces ketones, and you don't experience a massive energy crash. But when we eat every 2 hours, we never ask the body to make that switch. The machinery rusts.
And the engine itself, the place where this fuel is actually burned, is the mitochondria. I feel like mitochondria sit at the very center of this entire conversation about longevity.
Very much so. Mitochondria are the powerhouses generating our cellular energy. But here is the fascinating part that modern science is uncovering. Metabolic transitions, the actual physical act of switching from glucose to fat oxidation, creates a very specific type of adaptive stress. And that stress actually improves mitochondrial resilience. When the body periodically experiences fasting, intense exercise, cold exposure, or simply reduced glucose availability, the cells don't just shut down, they activate ancient survival pathways.
So it's almost like controlled adversity strengthens our cellular intelligence. We actually need a little bit of hardship to function optimally.
Precisely. In biology, this concept is called hormesis. It's the idea that a mild, temporary biological stressor provokes a response that makes the organism stronger and more efficient overall. By constantly sheltering our bodies from any metabolic stress, we are actually weakening our cellular infrastructure. These mild stressors improve our energy efficiency, our stress resistance, and our overall cellular maintenance.
Which leads us perfectly into one of the most exciting, almost sci-fi sounding areas of longevity research, autophagy. If hormesis is the workout for your cells, autophagy feels like the deep clean.
Deep clean is exactly right. Autophagy is fundamentally a cellular recycling process. Under certain stress conditions, most notably during fasting, cells realize that no external energy is coming in. So, they begin looking internally. They start breaking down damaged proteins, misfolded structures, and dysfunctional cellular components, and they recycle them for parts. Think of it as internal biological housekeeping. This cleanup process is absolutely vital for maintaining cellular efficiency and preventing the buildup of junk that leads to aging and disease.
It's incredible. So, periods of metabolic silence, just simply not eating for a while, actually trigger these profound repair mechanisms that modern humans almost never activate anymore.
That is a very important point. Continuous feeding completely suppresses autophagy. It's like running a factory 24/7 and never stopping the assembly line to do maintenance on the machines. Eventually, the debris builds up and the machines break. By living in an environment that promotes almost continuous eating, we are denying our bodies the opportunity to heal.
It really paints a stark picture of modern civilization. We've engineered this world of absolute convenience, but the physiological cost of that convenience is devastating.
Unfortunately, yes. Frequent glucose exposure means your insulin is constantly elevated. Over time, this contributes directly to insulin resistance, metabolic inflexibility, chronic fatigue, and wildly unstable energy regulation. The body gradually loses its efficiency in switching fuel systems. It simply forgets how to adapt. And this rigidity is heavily implicated in multiple chronic diseases.
Meaning, modern humans often become metabolically trapped in their own bodies.
Exactly. Trapped in a state where they are simultaneously overfed but undernourished at a cellular level.
And it doesn't just affect the body, it profoundly affects the mind. The brain's response to these different fuels is fascinating. I've noticed that when people talk about fasting or getting into a state of ketosis, the first thing they report is the sudden, sharp mental clarity.
It is a very active, very exciting area of research. The brain is an incredibly energy-hungry organ, and it responds beautifully to ketones. Ketones can cross the blood-brain barrier and provide a highly efficient alternative energy source for the brain under certain conditions. Researchers are currently investigating the potential relationships between ketone utilization and reduced neuroinflammation, improved mitochondrial efficiency in brain cells, and overall cognitive resilience. Remember, the brain evolved under fluctuating fuel availability too.
It makes total sense from an evolutionary standpoint. If you were a hunter-gatherer and hadn't eaten in 2 days, you wouldn't want your brain to get foggy and slow. You would need it to be sharper than ever to figure out how to survive. So cognitive stability may fundamentally depend on metabolic adaptability.
Very much so. The nervous system is highly metabolic. If your brain can only run on a steady drip of glucose, a missed meal causes a cognitive crash. If your brain is metabolically flexible, it just switches fuel sources and keeps you focused and alert.
This brings us to a really profound realization about longevity itself. We spend so much time obsessing over finding the perfect diet, counting every calorie, trying to achieve this ultimate state of biological comfort. But perhaps the deeper lesson here is this: longevity may depend less on constant abundance and more on intelligent adaptation.
Beautifully said. Biological systems did not evolve in a vacuum of comfort. They evolved through challenge, through variation, and through environmental fluctuation. Metabolic flexibility is simply the physical reflection of adaptability itself. And if you look at the entirety of nature, adaptability is one of the strongest predictors of survival in biology. Rigid systems fail under pressure. adaptive systems survive.
Meaning, health is not static optimization, it is dynamic responsiveness. It's about how quickly you can bounce back.
Exactly. And future health systems are going to increasingly focus on this. We are moving away from calorie obsession alone and moving toward metabolic intelligence. Wearables and metabolic technologies are now allowing us to track glucose variability, recovery, heart rate variability, sleep architecture, and energy patterns in real time. The future of medicine will likely involve highly personalized metabolic optimization strategies built entirely around flexibility and resilience.
We are finally getting the tools to see the invisible machinery inside of us. But the philosophy remains ancient. The human body was never designed for constant comfort or constant consumption. It evolved through variation, through challenge, through adaptation.
And perhaps true longevity is not about avoiding stress entirely. It is about developing the biological ability to adapt to it gracefully. Because at the foundational level, resilience is metabolic.
A powerful truth to leave off on. The next time you feel a little hunger, maybe don't rush to silence it immediately. Let your body remember what it was built to do. Let the engine switch gears. Adaptability is the foundation of longevity.